Do you know what is REST? If not, this is your chance to know the basics of REST. In this particular video, we are going to see what is REST, what are the basics of REST and HTTP, and what are the different maturity models which are there for creating a REST application. Let's get started.
Press the bell icon on the YouTube app and never miss any update from Tech Primers.
So the agenda for this particular session is what is REST, what is HTTP, what are the different REST constraints, a sample REST implementation, and also the Richardson Maturity Model, which explains what are the different types of levels which are there when we are creating a REST application. Let's see each of these separately. So what is REST? REST is nothing but representational state transfer. If you know about REST is just an architectural style. It is nothing else. It is not a framework, it is not a library to learn. It is an architectural style. So you can create REST applications in Python, you can create REST applications in Java, you can create it in Scala, you can create it in Ruby or any language. REST is just an architectural style. There is no underlying language, framework, or library associated with it. It is just an architectural style. It uses the HTTP protocol under the architectural style. So HTTP protocol is wrapped around the REST. So it is wrapped with a concept which is called the REST, and that is an architectural style. If you know about Taj Mahal, it is one of the world wonders. If you know, it is an architectural style. Underneath the Taj Mahal is the preserved body of Mumtaz, the wife of Shah Jahan, who built Taj Mahal. However, you see Taj Mahal as an architectural style because of the way it is built. But underneath, it's like a monument or it is created as a remembrance for somebody, right? Same way, REST is an architectural type. So, in order to know about REST, we need to understand the basics of HTTP as well. We need to understand what are the different HTTP methods which are out there to create REST implementations. These are different REST HTTP methods. These are HTTP methods in itself. These are not specific to REST. If you go to any website, if you go to any browser, you can see these different methods. So these are called methods or requests. Let's see that with an example, right? I have google.com open here. I'm going to inspect this page so that I can show you how this is coming in. So let me go to network. I'll just refresh this page. I'm not going to do anything else. I have just refreshed google.com and I see that there are so many requests which came here, right? Which went and came. And you see that these are different tabs here. So the status is nothing but the status of that particular request from the browser to the backend or whatever. And these things are done using the HTTP protocol, because the backend, if you see here, this is HTTPS to be specific, right? So it is the HTTP protocol. So if I click on this particular request, I have some options here, and if you notice here, there is an option called request method and it says get. So this is nothing but the method which is out there in the HTTP here. So there are different types of method: get, post, put, delete, and head. So if you notice, this is using get method. If I need to show you some post, right? So if you notice, this one is a post method. So this is generating some token or something. So it is having a post method here. So likewise, every request which is associated to a HTTP protocol will have a request method associated with it. It could be either get, it could be either post or put or delete or even head. So when do we need get, right? So get is usually a cacheable command. So you can use get when you want to cache something in the browser side as well. If you send some additional parameters to the request, then you will be able to cache it. So for example, there is a parameter called cache control here. This parameter is right now set to max age as 0. That means there is nothing which is cached in the request. So we won't be able to cache it. So you can do that using get. If it is post, we generally use post if we are sending a request or when we want to write something. That is when we use post. Or if you want to generate something or you want to create something, that's when we use post. So similarly, how Google used here is they are generating some token out of it, out of the request which I sent. That is when they are using post here. Put is something similar. Put is similar to post. You can create that, but if you want to have a differentiation between an update and then create, that's when you go for put. What you can do is you can do create using put, and you can do an update using post. That is when people go for post versus put. Delete is when it's straight away clear, right? When you want to delete some data, you can directly use the HTTP delete method. Head is used when we want to request or when we want to get the response status only and the header information from the server, but we don't need the body. That's when we use head. So we want to send a request, we just need the header information, we don't need the response or the body information. That's when we use head, right? So these are different HTTP methods which are out there, which we'll be using inside the REST protocol as well, because the underlying protocol which REST uses is HTTP. Now, what are the different constraints inside REST? When we want to create REST implementation, what are the different constraints which we need to consider while designing a REST application? The first one is the client server implementation. The REST constraint says that we need to have a client server based application when we are using REST. Basically, you have a client, you have a server, and the client requests the server for any information, and the server should be able to respond to the client separately. Instead of having a single monolithic application, you should have a client specifically and you should have a server. That's when the REST implementation would make sense, because the server doesn't know what is the client doing. It just asks for an information and the server just gives that. Typical example would be, let's say a user information is stored in a database. You have a database process or the backend process which is going to be implemented with REST, and you have a UI. From the UI, you will be sending a request to say show user, and this backend server will go to the database and retrieve that information and then return it back to the user. So the client will not know what is happening in the server. The server will not know what is the client doing across. So it will just respond to some message based on the type of query the client is asking. The server will be able to respond. So that is how you should define or design an application using the client server model. So if you have already worked on client server based modeling, then you don't have to worry about it. You already know what is a client, you already know what is a server. It is exactly the same. Underneath the client server, why we did that? Because of the separation of concerns. As I said in the example, right, the server's responsibility is just to fetch the data from the database, and that is what the server's responsibility is. The client's responsibility is just to collect the data and show it up to the user. That's what the client does. Same way on the server side, if you can split the server into different distributed systems, let's say you have a user request service, then you have a payment service, then you have an inventory service or something like that. You can have separation of services so that it's easy for us to directly query each service, and that is how microservices design pattern works, right? If you know about the service based architecture or service oriented architecture, or if you go to distributed architecture, the services are split based on their functionality. So REST is used most often when you have like microservices design pattern or distributed systems where you have client server architecture and the servers are all split based on their functionality. That way you have a separation of concern for each specific process. The next constraint is stateless. The REST endpoint should be stateless. What it means is that if, let's say, there are multiple clients which are accessing the same server, every client should get the same response. Let's say there is a user who is requesting the server to give some information. At one point, the server should be able to give the same information for all the clients which came at the same time, right? That is when you don't maintain a state in the server side. So maintaining a state in the sense you just record something and then based on that you respond to the user. So we should not have any stateful information. Rest should be stateless. So when you query something, you should get that response every time. You shouldn't be having different logic for different clients. So that is how REST should be designed. It should be stateless. It should be cacheable as well. So if you have any caching logic on the client side, let's say the client wanted to have a caching logic, you should be able to cache that so that the client has flexibility to cache the data, and if they don't want to cache the data, they should be able to decide whether they want to cache it or not. Uniform interface. What do you mean by uniform interface, right? So you can identify resources using some common set of names or something similar, which we will be seeing in the next few slides. However, uniform interface is something where you can easily identify your REST endpoints based on the type of functionality you have. For example, if there is a user, you should be able to identify the features of the user under the user resource. So we'll see what is a resource. So based on that, your constraint should be aligned. So that is what unified resource interface mean. Identification of resources should be easily available for us. The next one is the representation. How do we represent that particular method? So either it is a get or a post or a put or a delete, however we want it. Self-descriptive messages. How should the resources name look like? So it should be self-descriptive. If you are going to add a user, it should be user, or you can say add user. It depends on how you wanted it to be. Some people use directly user, some people use add user, delete user separately. However, the general notion is it should be self-descriptive, and we will see that in the future why we should do add user or why we should not do add user or something like that in the next few slides. The last one is the hypertext as the engine of application state. So if you would have heard about HTOS, that is another way of linking two different REST endpoints in the same REST endpoint. So you have a single REST endpoint, you trigger that particular REST endpoint. Inside that particular REST endpoint, you have links to the subsequent URLs. So that is HTOS. The last one is the layered stream. The data should be layered so that the processor should be able to easily talk with each of their different components. So the implementation should be layered. This will restrict the knowledge in each layer of the component. So when we are defining or designing an application, we should have different layers in the application where you have segregations of concern so that you don't have to talk with each and every part of the application. So this restricts the knowledge in every layer which we design. One major disadvantage of this particular layered system is latency will be huge and it adds to the load. So it is typically an overloaded system. You will have so much of hops, you will be doing so many unnecessary lookups. That will be an additional overhead in the layered system. So now we have talked about REST, right? Let's see a sample implementation about REST. This is a simple pet store example. Swagger had exposed a Swagger UI, and it is the best example which I can show you. If I write a new application, it is going to take me so much time and I need to create documentation around it. Instead, I just wanted to see an existing implementation which is good, and I found out this particular example from the Swagger website, which is called the Pet Store. This is the sample implementation of the REST API, and this is the Swagger UI, which is just showing what are all the REST endpoints which are available on the server side. If you notice here, this is a pet resource. So this is called a resource /pet. A resource is nothing but a path from where it starts. So this pet resource is nothing but a feature. And you can notice that this says everything about pets. So under pet, you will have everything about pet. If you want to add a pet, you will be having a post. See this, right? There is a post with which you can add a pet. If you want to update a pet, you can do put. If you want to get something, get a particular pet ID, you can use by a get. If you want to delete a pet ID, you can use via the same pet, and you just need to pass that using a different HTTP method. So these are the different HTTP methods. Based on that, the resources are changing, and based on these two combinations, there will be implementation. So for post and /pet, there will be an implementation on the server side. For the put pet, there will be an implementation on the server side. Same way for get, delete as well. And if you notice, Swagger is just showing you what type of model you are going to send, and you can test some data here itself if you wanted. So this is how you can design a REST server. And /pet is a resource, post is post, put, get, all these are the HTTP methods, and these are just the parameter types. There are other implementation as well. For example, there is a store resource, there is a user resource where you have lots of again methods, user, post. You can see this, right? You have different types of implementation. You have a create with array, create with list, then you have a user login, user logout, user slash the username, post, put, and delete for all the same, right? So this is a simple example of a REST implementation which you can do. So if you are not aware about how to design REST implementation, go take a look at this particular website, petstore.swagger.io, where you can see an implementation or an example of REST, how you should create a REST implementation. The next one is the Richardson Maturity Model. This is the guide which was created by Martin Fowler based on Richardson's idea of breaking down the principles of REST into three different approaches. We are going to see the model. The first one is the level 0. So level 0 basically it doesn't do anything. In general, what Martin Fowler says that is, as a part of level 0, we should have created a web request which can be of any type. It just needs to use the internet to traverse. So it can be HTTP, it can be remote procedure call, anything. As a part of the level 0 maturity model, you should have a endpoint exposed, which can be anything. So let's say there is an endpoint called add request. We can expose that REST endpoint with some technology. That is what level 0 is, and this is the level 0 of the REST implementation. Level 1 considers resource creation. As we saw in the previous sample example, we should be able to create different resources. Example, the add resource, add inventory, or add account. These are different resources. Under that you have different methods or different sub resources where you have their own implementation. So this is when an application reaches a level 1 maturity model, when it is using resources to have different endpoints and it is not using a common endpoint. Like in the previous case, in the level 0, there was only an option called add request, which was adding all the users, inventory, account information. However, in the level 1 resource, we have split that into three different parts: add user, add inventory, add account. So this way you have separate resources, you can have separate code, you can have separate implementation. You will be able to follow the constraints which we saw right earlier. The next one is the level 2, where we need to consider using HTTP verbs. So instead of adding the add user, we will be using a user. That way, under the user, you will have addition, deletion, or updation happening. Same way for the inventory and the account as well. That way, you know that it is simple to understand rather than adding a add user, delete user, or add user with array or something big. This way, if you try to create that by creating verbs, then it is easier for us to understand and the resources are much simpler. Level 3 is the hypermedia controls. If you know about the HTOS, HTOS is nothing but the level 3 concept. So you have a REST endpoint. Let's say there is a REST endpoint called /user/123. If I hit this particular get request, I'll be getting a response of a particular user information, and that particular user information has links to subsequent requests. So for example, here I have link to the account information here. So this is hypermedia control. So using one request endpoint, I have links to subsequent REST endpoints. I don't have to remember these because I query this and I get that particular link automatically from here. This is hypermedia controls. So if your application follows these three concepts, then you are in the level 3 maturity model. This is what Martin Fowler has created based on the concept developed by Leonard Richardson, who created these three concepts, and Martin Fowler created these as Richardson Maturity Model so that your application can be aligned to this model and the maturity process. So what did we discuss as a part of this particular video? We saw what is REST, we saw what is HTTP, we saw the basics of HTTP as well. What are the different constraints? We saw a simple sample, pet store, which was implemented using REST. We also saw what is the Richardson Maturity Model. I hope you guys understood the basics of REST from this particular video. If you have any doubts or concerns, do let me know in the comment section below. If you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.